Hi everyone, we are Team 10 and we will be presenting our project on eye gesture classification using machine learning models. So a short introduction about our approach. So the goal is to use both supervised and unsupervised machine learning models like SVM, random forest, CNNs, hierarchical clustering, K-means, and Gaussian mixture models to classify the eye movement images into three categories, like which is right, left, and center. So we observed from our literature reviews that there was a problem of accuracy when we're using KNNs in different literature. And so we aim to use the above mentioned models to find out the accuracy and see whether that accuracy can be improved. So the motivation behind this project was that there is a lot of use case in terms of using such eye image classification methods, and especially when we want to decode the information contained in facial cues. And detecting eye movement could have potentially life-changing applications, especially when we want to scale up our project for motor disabled patients. So moving on to the data collection, we used two sources of data. One is the eye data set and the other is an internal data set that we compiled. So the eye gesture images were collected from patients with and without motor disabilities. And there were a total of 14,997 images in the eye data set. And the annotation contained information about the position of iris, size of the iris, size of the pupil, and size of the eyelids. The internal data set, on the other hand, was created by us and pre-processed. And this was combined with the iData set to give a combination and to give more images for training. Moving on to the data pre-processing, we used the data set. The internal data set was captured from different frames in the webcam, and we used the CV2 video capture function to capture these images. And we converted the images to grayscale, and we also cropped the eyes from the images because that was the data relevant to our project. And we also equalized the image using the equalize histogram function and to improve the contrast, and we normalized and resized the images. Then we performed a feature reduction using PCA. We wanted to retain the top 60 principal components, and we resized the images from 120 by 120 to 60 by 60. And this was done using the PCA and feature reduction technique. Moving on to the methods. So for our SVM, random forest, CNN, hierarchical clustering, K-means, and Gaussian mixture models, we pre-processed the data and we used these methods to find and we also evaluated these methods using accuracy metrics and to find out which method best suits our model and our data. So the first method that we implemented was the CNN. The CNN was trained on labeled images using backpropagation and SGD. And we evaluated the model on a separate test set, and we used two layers with the ReLU activation function. So as you can see, these are the layers that we used. So we used two layers, and we also used flatten, and we used dropout to reduce overfitting of the model. And one more thing that we used was the ADAM optimizer for the hyperparameter tuning. So we use this optimizer because it has a history of adapting the learning rate to the based on the historical gradients. And it's also very flexible. So that's why we went ahead with the ADAM optimizer. The next model that we implemented was the random forest. So this is an ensemble machine learning algorithm, which was used for both classification and regression tasks. And we imported the random forest classifier from the scikit-learn library. And for this, we used the training data was flattened histogram of pixel images. Here, the hyperparameters were, we used the number of estimators as 100 and the random state as 42. And we wanted to, 42 was used so that the outcome is uniform throughout, depending on the number of iterations we use. And then the next model that we used was the SVM. So this is a linear kernel technique, and the way it works is the linear kernel maps the input data to a higher dimensional space, where it's easier to separate the classes with a linear decision boundary. So as we in the SVC classifier, we used the kernel as linear, and we also predicted based on the classifier predict task. The next model we used was the Gaussian mixture model. This is a probabilistic model, and the goal of this model is to maximize the log likelihood. Here we used a transfer learning model called VGG16, which was trained on ImageNet data. And we also used PCA to reduce the feature set, like I mentioned before in the previous slides. And the number of components we used were 3. The next model we used was the hierarchical clustering model. So the way it works is that there's a top level cluster that contains all the data points, and the subsequent clusters contain similar data points and similar smaller clusters, basically. And here we also used PCA here, and the number of parameters or number of clusters we gave was 3. And this is a dendrogram plot for hierarchical clustering. As you can see, there's a top level, and the bottom level contains similar clusters denoted by these images. The final model we used was the second last model we used was K-means clustering. So this is an unsupervised learning model. So it basically clusters based on the K value that we give. Here we gave 3 because we wanted 3 clusters. As you can see, K-means separated the data points into 3 separate clusters. Now, moving on to the results. This is a table of our supervised learning accuracy comparison. So we have CNN, Random Forest, and SVM. And we have unsupervised, which is the hierarchical clustering, K-means, and Gaussian mixture model. And we basically compared based on the F1 score. And as we can see, SVM has the highest F1 score in our supervised learning models. And K-means has the highest F1 score among the unsupervised learning models. So we can conclude that the SVM and K-means fit our data very well, and they are the best models to use for our image classification data. And these are the references. Thank you very much.